Okay, welcome to the lecture dealing with proofs. This is our first pass of many to come. In fact, this homework 2 and homework 3 form a pair because they're basically the same thing. So the first one's going to be a little rough, and then to get more practice, that's what homework 3 is about. But before we get to that, let's talk about a proof. And even before we talk about what a proof is, let's recall back to homework 1, where in 2.1 and 2.2 we talked about the notion of validity. We talked about it earlier as well, but we tried to apply it there. And if you remember from the picture and audio files, or audio file, it was mainly a conceptual structure where I explained if the premises are true, the conclusion must follow, and then applied them in those cases. 2.2 was the same, but with differing materials outside of our language, but still the same idea. If it was conceptual there and you sort of understood, okay, the conclusion has to follow, what about in general where you have to show how something must follow? That's what a proof essentially is. It's an unbreakable chain of inferences. The idea is granting certain premises, if you show that from those premises step by step, you build a chain where each one has to follow from the previous ones, then that must mean when you get to the conclusion, you have to accept that given the premises. And that's basically what a proof is. It's an unbreakable chain of inferences that, if you think about it, shows validity. If the premises are true, the conclusion must follow because you've built an unbreakable chain where those pieces of the chain, bit by bit, have to follow to the conclusion. Okay. In the book, there's a distinction between informal and formal proofs. Since we're doing mainly formal proofs, that's really all you have to worry about. And you're going to have a sort of rough time with these initial proofs, sort of thinking, I can't really solve it, I'm using your guidance. But that's fine. What this homework is about is mainly getting familiar with the program Fitch. And also, if you can follow my reasoning step by step, that's all that matters. Learning to construct the proofs, getting them to check out, and then getting it in, that's the main thing at this point, okay? So for formal proofs, there are two rules that you're going to essentially use. One is called Anacon, which is short for analytic consequence. I'll explain what this rule means later in the course. But basically, it says if you understand the meaning of something and you see that something else has to follow, Anacon is the rule that will justify that. To use one simple example from the lecture, if you're given A is left of B, you understand the meaning of left of, and so you can say from that it must follow that B is right of A because they say the same thing. Anacon is the rule that gives you that. There are two other rules, and they have to do with a symmetry involved. There's a intro and an elim. In this case, there's equals elim and equals intro. The elim and intro aspect I'll explain later in the course, but for now, just be aware that there are these two sides to every rule. Yeah. Let me just quickly explain equals intro. Equals intro says you can always say at any point in the proof A equals A, B equals B, and so forth. Albert equals Albert, Bill equals Bill, U equal U. It's basically saying any object is identical to itself. That's obvious. It's always true. Here's the point. You're not really going to use it, so don't worry about it. It's the other one that you will use and you do have to get to know. That other rule is equals elim. That's its formal name. Its informal name is substitution, and you're actually already familiar with this in mathematics. If I tell you, and think of substitution, right? If I tell you x equals 5, and then I give you another equation, x plus y equals 10, what do? You can substitute in for x with 5, and then solve for y. There's an underlying logic to that, and that's not coincidental. Logic, again, as I mentioned before, is the glue holding mathematics together. It's the reasoning behind various kinds of things. There's a form to that pattern of substitution. Its formal name is equals elim, but its form says if you're given some predicate p, that's what the p here is, and you give some constant, let's say s, it doesn't matter, but I'm just using s as an example, and you're given secondly an equal statement, s equals k, you're allowed to substitute in for s with k to get p of k. Okay? Let's use something concrete. So when I talked about the substitution for mathematics, that's fine, but let me use a different example. Suppose I've got Superman equals who? Clark Kent, right? And then now you've got to describe Superman. Superman what? That's what the P is. Any descriptor. So let's make it easy. Superman flies. That's my P. Flies, right? So if Superman flies and Superman is identical to, is equal to Clark Kent, K, then I can substitute in for S with K to get P of K. Clark Kent flies. People don't know that, but it's true. He can. And that's all equals elim says. It's that pattern. All right. You guys can read the rest of the lecture on your own. Let's move on now to the homework. But before we get there, there's another concept you're going to need that's involved in the homework. Besides that of proofs, which I just covered, it's the opposite of what proofs show. It's the concept of invalidity. So again, if proofs get at validity, right? If the premises are true, the conclusion must follow. Then how do you show that there's something that you cannot prove, that it doesn't have to follow? That's where you get the concept of invalidity. So if you remember from last time and some of the initial lectures, the definition of validity had actually two definitions. There was the first one, the primary one, which was if the premises are true, then you're forced to the conclusion. It must be true, right? And then there was the second definition. It's impossible for the premises to be true and conclusion false. How is that equivalent to the first definition? Well, keep in mind the first definition. If the premises are true, so right here, you got the premises true. I asked you the question, can the conclusion be false? No, because if it's valid, assuming the premises are true, you're forced to the conclusion. The conclusion must be true, right? So that means you cannot have a false conclusion. So it is thereby impossible to have true premises and a false conclusion. That's why the second definition of validity is equivalent to the first. This second one is useful because it directly relates to the definition of invalidity. What's the opposite of impossible? Possible. What's the opposite of validity? Invalidity. So the definition of invalidity is it is not impossible but possible for the premises to be true and conclusion false. The intuition behind this definition is that if you're not forced to the conclusion, that is to say, the argument isn't valid, it is invalid, then that means it's possible for you to show true premises, but you're not forced to the conclusion. So that means the conclusion can't be false. Okay, if you didn't get that, we're going to illustrate that in the homework. So let's get to the homework. Homework, the first one, 2.8, I actually have it laid out in the lecture and in the audio file, and I also have video to go along with it, so you should check that out. So what I'm going to do now is cover 2.10, which is the same thing as 2.8, but I'll just cover it here in the video to give you guys a feel for how it works, okay? So let's go to the book and Tarski, and if you notice 2.10 here, there it is. As with 2.8, there's an arrow pointing up / pencil pointing down. The reason for that is simple. There's a question here. The question is it valid or not, this argument, right? For 2.8 as well. The pencil down says if it's valid, do an informal proof and write it out. Okay, I haven't covered informal proofs in the course, and we won't for the most part. So don't worry about that. The other option, though, the point here is that if the argument is valid, show it. The other option here is invalidity. If it's not valid, invalid, turn that in via world. That's the arrow pointing up. It's one or the other, never both. An argument is either valid or invalid. It can't be both. That's what the book here is indicating with these two options. It's one or both, one or the other. Show which one it is. So I've written it out on the right side here in the sentences in Tarski. You don't need to do that, but I've just had it here for your guidance. And the two premises are B is the same size as C, B is the same shape as C. Does it have to then follow that B is equal to C? Well, you might think about it intuitively. If you know that B, whatever it is the same size as C and it's also the same shape, aren't they the same? Thereby the same, so aren't they equal? And you might think, well, yeah, they're equal, so this is valid. But it turns out it actually isn't the case that it's valid. Let me explain that using a parallel example. If any of you seen the movie, I don't know, it's called like The Sixth Day, I think, something like that. It's this crappy 80s movie with Arnold Schwarzenegger. It's a good example. There's others, but this is probably the best one that fits this case. So there's a bunch of clones running around. They're all Arnold Schwarzenegger clones, right? And there's this machine that uploads the memories of one Arnold to the other. So they're not just the same size. B is the same size as C. They're big, bulky, and they're same shape, big, bulky, and they got the same memories in addition and the same crappy accent. I'm Arnold. And the other guy says, no, I'm Arnold. Shoot him. right? And they're both talking about how they're the real deal. The question is, if they're the same size, same shape, same memory, same everything, they're qualitatively and quantitatively indistinguishable. Are they then one and the same person? Well, it might seem so, but in this case, it's clearly not, because one person's saying, I'm the real one, shoot him, he's not real, and the other one's saying the same thing. So they're not actually, strictly speaking, identical. They aren't one and the same, and that's what equals means. If you remember, equals means one and the same object. Clark Kent and Superman aren't separate creatures, they're one and the same person. So to show that this argument is invalid, show that it's possible for the premises to be true but conclusion false, here's the counterexample. I create in the world just two objects. I name one B. I name the other one C. I then check it, and what I'm going to find here is that, take a look, true premises and a false conclusion. So even though they're the same shape and same size, they're not one and the same. The identity that we have here is strict. It says in order for something to be identical, they have to be one and the same. There's an inverse of this in philosophy that says if two things have all the same properties, then they're the same. This one, our identity, says if two things are equal, then they have all the same properties. The reverse of that, these two things have the same properties, thereby they're the same. It's philosophically interesting, and it's not the same as what we're using here, but it's related. Let me give you a brief example, a philosophical example of how this stuff gets applied in quote-unquote the real world, or at least in the realm of ideas. Okay? So think of your personal identity. You think you're the same person from when you were at birth until you die, right? And nothing changes. You're not the same size and same shape. Things change, but somehow you think you are the same. So what does it mean to be identical to yourself? Is it because you're the same as yourself that you thereby have the same properties? Or is it the reverse? You have the same properties more or less, but even if some of them change, you're thereby yourself. What? If that doesn't make sense to you, let's just reflect on this more commonsensically. Forget for the moment this stuff with equals right now, okay? Just common sense. You think you're the same person throughout your life, and yet we know from science that, roughly every so many years, the cells within you change to the point where you are new material. So physically speaking, whatever the you in you is that makes you the person that you think is the same, it can't be, strictly speaking, that physical material, because it keeps interchanging. The cells die off and you get replaced. In philosophy, there's this problem called the ship of Theseus problem. And it basically says there's this ship, and it's got some boards on it that are rotting, and you have to replace them from time to time. So you replace one or two. Is it still the same ship? And everyone says, of course. Okay, suppose more rot and you have to replace some with wood, some with metal. Is it still the same ship? Yeah, of course. What if it comes to the point where you've replaced all the boards and planks on the ship with new material? Not just wood, but some other stuff. Is it then the same ship? And at that point, people are like, I'm not so sure. Well, at one point, it was a wooden ship. Now it's a metal ship. Or maybe it's a ship made of gold. I mean, just, it doesn't float anymore, but someone put it in a museum. Is it the same ship? Some people would say, yeah, it's the same. Others would say, no, not really. Now apply that to yourself. How much of you has to change so that you thereby retain your identity? What if you get hit on the head and you get knocked out and it discombobulates your brain to such an extent that you can't remember those around you that you love? Physically speaking, you're the same. Everyone sees you and they say, oh, Ralph, nice to see you. But you don't feel the same, and you don't even recognize these people. Are you the same person? And most people would say at this point, sort of, but not really, right? Another way in which this has been applied in philosophical discussion in what's called philosophy of religion is whether or not there's something like transmigration of the soul, or more commonsensically in the Judeo-Christian tradition, the idea that the soul somehow is what's real, the body dies, but the soul goes on to heaven or hell. Is it the same person? And the standard reigning dogma is that you're the same person. You just get transferred to this other realm. And the ship of Theseus problem raises this issue. If enough of you is transferred over, are you in fact the same or not? If your body is essentially a part of your identity, in whatever sense, and it doesn't survive death and it gets carried over into, let's say, heaven, let's say your physical ailments, not just your physical body of what it looks like, but the physical aspects of you. You say your cancer, or say your disability, or whatever it is about that's unique to your physical body, actually becomes a part of who you become, your personal identity, who you think you are as a person. If that gets removed and you get transferred, let's say, over to heaven, the big question remains, are you in fact one and the same person? This kind of logic that we have here, same size, same shape, raises that same problem. If you remove sufficient of these properties of yourself, when does it sort of become, when does that change occur whereby you're no longer the same person? If you're, say, a disabled person, and that's fundamentally tied to your identity, the overcoming of that, the dignity involved in it, and so forth, and then that gets removed and you get moved to heaven, are you one and the same person? Some people would say, well, yes, I am. Others people would say, not really. I've become a different person. And that's what this notion of identity gets, where it gets raised, and how this logic gets applied in these philosophical problems. It's really interesting beyond this course, but again, as I mentioned before, the more we get under our belts, the more I can show you other philosophical examples of this stuff. Okay, that's 2.10. You're just going to turn in this world, save it as world 2.10, and turn that in. And if you look to the lecture, back at the lecture, I've also got for 2.18, which is the first proof you're going to do, I take you through that in the audio file and also the picture file, and I have a video there as well. You should watch that. 2.20 then allows you guys to try this out on your own. I'm not going to take you through that. I have a podcast, again, the audio file there to guide you, as well as a picture file, but I want you guys to try that on your own. Make sure you use those materials there. Okay, this concludes the video lecture for our first passive proofs.